I'm going to be talking tonight about two things that I really love as a front-end developer for the modern web. The first one is React, which I think we all love, and that's probably why we're here. The second is a newer programming language called ReasonML. And I'm pretty excited to share with you kind of some of the cool features of it. By show of hands, has anyone heard of ReasonML here? Has anyone used ReasonML here? All right. There's some fellow nerds in the audience. That's always great to see. Awesome. Before I begin, I am actually going to reveal that I am Gilderoy Lockhart, and I am here as your defense against the dark arts teacher. No, that's utter nonsense. I am actually, my name's Parker. I'm a software developer, software engineer at Formidable. I am Parker Ziegler on Twitter and Parker Ziegler on GitHub as well, so that's how you can find me. For those of you who don't know about Formidable, we are a JavaScript consultancy for the modern web. So we work on React, React Native, GraphQL, Node.js, getting into ReasonML now, and kind of the extended web ecosystem. We also do some like back-end full stack stuff as well. And we have offices here, but also in London, Denver, Phoenix, and I actually have some coworkers from a bunch of those offices here tonight. Yeah, it's a really great place to work. You may have also heard of us through our open source work. That's kind of how a lot of people get to know us. You might have seen projects like Spectacle, which is actually what this presentation is made with. There's also Victory, which is a data viz library for React. And then just recently we released Urkel version 1, which is a GraphQL client for React. Kind of like a Apollo client, but a lot leaner and tighter. And as a software engineer at Formidable, you're going to be involved in open source. So if open source is something you care about, definitely come talk to me about working with us. I worked a lot on Webpack Dashboard and also Urkel over the past year. So I'm pretty involved with our OSS. I'm also really, really into ReasonML, and I'm starting to write some of our first open source in ReasonML, and we've just started releasing that in the past few months. I'm almost like too much of an evangelist at work. We were talking the other day about which new modern language has the best error reporting, and I was like, oh, Reasons is so good, so much better than Rust. And someone was like, Parker, like, is this just you plugging Reason again? And I'm like, this is just me plugging Reason yet again. But it's because I really love Reason, and really in this talk tonight, I want to try to convince you of two things about Reason and two things about programming in general. The first is that using a truly sound type system can fundamentally change how you write code for the better. So how many people here are using TypeScript or Flow in their everyday work? Right. So a lot of folks. The web is moving towards static typing. We're starting to see the benefits of having a type system, but the type systems that have been developed for JavaScript are okay at best, and I'll explain sort of some of the shortcomings or where they fall short tonight. The second part of the talk is like, you don't actually need to write JavaScript or TypeScript to write React now. ReasonML provides a pretty cool interop for you to actually write React code in a different language. So we'll be talking a bit about that tonight. Now, you're probably, for those of you who haven't heard of Reason, you're like, cool, what is this? Like, why are you talking about it? What does it actually have to do with React, and why should I even care? It's 8 o'clock on a Wednesday, and I've had 2 beers, and I'm kind of ready to go home at this point. But there are many reasons you should care. So to put it really concisely, ReasonML is just a syntax for OCaml that looks a lot like JavaScript. And that probably doesn't give you a good sense of what it actually is, right? Because many of you maybe don't know what OCaml is. Something that might help you kind of like get more into this is that it was authored by Jordan Walk, who is the original author of React. So it's kind of blessed by kind of the original mind of React. And what's interesting is that when Jordan was prototyping the first versions of React, before it was written in JavaScript, he wrote it in standard ML, which is sort of an ancestor to Reason and OCaml. So he kind of opted for a language that provided a super sound type system rather than going to JavaScript first. So it's kind of interesting to see that the history of React kind of owes itself to this past. So to understand what reason is, we kind of actually need to learn a bit about what OCaml is. So OCaml is a functional, statically typed language, and it's known for systems programming for the most part, kind of nothing to do with the web for a long time. And it's powerful type inference. It's considered to have actually the best type system of any language pretty much out there in existence today. It's about 20 years old, and it's mainly been an academic language. So it's received kind of decades of engineering, but it's been kind of confined to the esoteric academic computer science field. That all sort of changed when Facebook wrote Flow, which is their type checker for JavaScript, and Flow is actually implemented in OCaml. And that was when Jordan kind of first started getting this idea of like, what would it look like to write a language that takes all the great parts of OCaml, but actually kind of makes it look like JavaScript. So in OCaml and Reason, types are inferred and validated at compile time, not at runtime like they are in JavaScript. And you're like, sweet, like TypeScript already does that, dude. Like, sorry. And to that, I would say, kind of. So let's take a look at a quick example of kind of TypeScript versus Reason and how those two things differ. So here's a sample of a really simple identity function in TypeScript. It just takes in an input and returns that value. Now, if you don't write any types, if you don't annotate any types in this expression, TypeScript actually evaluates the values of foo and bar to be of type any, right? So even though you called foo with a, like the string a, or with the number 1, TypeScript's basically, without you providing the types, it's kind of like I don't totally know what this is. It could take in anything and it's going to return anything, so I'm just going to say it's any. It gives you kind of like the broadest type that it can possibly infer. And you only get good type checking if you actually write the types. In Reason, it functions a little bit differently. Reason uses type parameters, which are kind of like generics in TypeScript, but it uses them automatically. So you don't annotate your types, but it actually supplies those type parameters for you, and then it infers the types from your usage. So in the case where you call the ID function with an int, it automatically infers that your variable is going to be of type int. The same thing with a string. And kind of the reason for this difference is that Reason has a fundamentally different type system underneath. It actually uses something called the Hindley-Milner type system, to get very academic on y'all. And kind of the core premise of that is that for every expression, there can only be one type that that expression can evaluate to, right? So this is different than JavaScript. In JavaScript, you can have a function, you could return a string, a number, an object, an array, behind all sorts of conditionals. In Reason, you can't do that. And the benefit of that is that we can soundly infer all of your types at compile time without you ever writing types. So it's a pretty cool benefit for what I think is kind of a small trade-off. So cool, like the type system is really great. What else is cool about Reason? What's pretty badass is that it has native performance that's close to C and C++. So Reason cannot just compile to JavaScript, but it can actually compile to native code that's going to be running in a bunch of different environments. You can use this to run desktop apps. You could use it to run mobile apps. You could put it on an IoT device. And it runs really, really fast and really, really close to the metal. But it has higher level abstractions like garbage collection and memory management and all of these things that are a little bit nicer. So it's pretty cool for those uses. The last thing is, I mentioned it's a functional language, but it actually supports side effects and mutation, which, as Ken Wheeler says, are the two things that actually allows it to go into production. A lot of functional languages are notorious for being hard to use, and side effects and mutation make Reason really easy to use. Cool, so we've kind of talked about like Reason as a syntax for OCaml that just kind of looks like JavaScript, and somehow like we get that code to the web, but there's kind of this step in between that we're a little bit like fuzzy on. So that step is actually kind of a newer project called Buccal Script. What Buccal Script is is basically a compiler from OCaml to JavaScript. So it's going to take your OCaml code and compile it down into ES5 compliant JavaScript. You can also target ES6 or even down to ES3. It's a really, really cool compiler. And in this case, it kind of takes the place of something like TSC or Babel, so you don't actually need to use those to output your JavaScript. And what's pretty rad about it is that it is super fast. Bob Zhang, who is the author of Buccal Script at Bloomberg, he benchmarked a project of 5,000 OCaml files, running it through the Buccal Script compiler, and it took 260 milliseconds to compile 5,000 reason files, or OCaml files, into JavaScript. Compare this to like TypeScript, where you have like 100, 200 files, and you're like waiting around for 10, 20 seconds for it to compile. So these kind of like fast rebuilds are pretty insane. And as the cache gets warmer, Buccal Script will compile faster. And I'll show you some metrics on that in a second. Another cool thing is that it actually outputs kind of like human readable JavaScript. So this is from the Reason online REPL. On the left side is Reason code. We have kind of like a classic add function and a square function, and we compose those two functions into an add and square function. And you can kind of see on the right, there's like some of this camel like interop stuff, but for the most part, like you can read that code and kind of know what's going on. It looks like JavaScript that I can actually read. And that's pretty cool to get compiler output that's fast, but that I can also debug and actually look at. So yeah, this is kind of the tool chain that we're working with for the web right now in the Reason world, and it's pretty exciting. Especially because the performance is so good, and the JavaScript that is output is often more performant than what you would write by hand. It's kind of optimized for a lot of the modern JS engines. Awesome, so we kind of got through that, like, here's the stack we're working with. What does this have to do at all with React? We're at a React meetup, and we haven't even really talked about it. So Facebook is kind of the core backer of Reason ML, and Jordan's team there is kind of really pushing it. And they were actually converting the Messenger app over to being written in Reason, which it is now today, an app of millions of users being written in Reason in production. And to do that, they created Reason React, which is basically a set of bindings to React for Reason. And it basically allows you to communicate with the Buccal Script compiler, write your React code in Reason, and compile it down into pure like JavaScript React code. So it's kind of cool. You can kind of think about this like writing TypeScript definitions for a library. But in this case, this has been sort of fully blessed by Facebook and is used in production a lot today. And it's really cool. We're going to take a look at what a component looks like in Reason React. And what you'll kind of see is that it doesn't look all that much different from a function component in JavaScript. We have this @React component on the first line. That kind of does a whole lot of the type checking behind the scenes for us. What's cool about Reason is it actually allows flags like this that will rewrite your AST under the hood. So it actually provides a ton of the type checking. And then your props actually come in as these labeled arguments into this make function. So those are all of your props. And then you're just kind of writing JSX like you do in React, except in the case of something like onClick, you don't have to say onClick equals onClick. It just kind of picks it up and knows for you. It's kind of like object shorthand syntax. So this is what a component looks like in Reason. This is 100% type safe with 100% inferred types. If you look at the same component in TypeScript, you'll see like it gets a little bit bigger. Like there's actually considerably more code to write. We're defining an interface for the props that are coming in and defining our component as a function component that takes these props. And you'll notice too that like we have to import React and export this component to use it. In Reason, you'll see that there's like no import and export syntax. And that's because Reason's module system is actually automatic. It can actually basically find all of the files in your directory, and it brings them into scope, and then you can kind of selectively open those modules as you need. So gone are the days of 30 lines of import files or imports at the top of your files. and now you just get to write your code and sort of reference things safely as you need them. So I think there are a lot of like benefits here. We get a much terser syntax. There's just less code to read and less for us to think about as developers. We get this 100% type safety and type inference without ever having to write our types. I mean, how many of you have been in a TypeScript code base where for the first month, people are like good about writing their types, they're defining their interfaces. Month 2 comes along, you start to see some any's pop up. Month 3 comes up and you're like, why aren't we just using JavaScript? Like, this is just painful. I'm in one of those code bases right now, and I know that Reason would solve so many of the bugs that we're hitting. So I really kind of love this feature of it. And then as I talked about before, kind of millisecond level feedback that we're getting. I actually benchmarked this component in Reason, like how much does it take to compile an entire Reason project with this component. It takes about 97 milliseconds from a totally cold start, and then on each rebuild, it gets incrementally faster. And I actually went about 5 rebuilds after this, and I got it down to 9 milliseconds to rebuild. So you're getting just instant feedback about this. There's no more kind of like waiting for Webpack dev server to like catch up with things, or for TSC to like finish type checking everything again. This compiler is fast and it's accurate. So that's kind of the core promise here. So what about hooks, right? Like, if we're gonna be writing modern React, we probably want to use the new hooks APIs, and you're like, if this is newer, is it gonna be supporting hooks? Like, do we get hooks? And it's like, heck yes, this supports hooks. It's pretty exciting. Ricky Vedder at Facebook kind of just finished this off about a month ago, and I was sort of anxiously talking to him about this release, and it's pretty awesome. The kind of longer answer to this question is that like the hooks API looks just slightly different from React. Use state, use reducer, those are basically one and the same. But all of the other hooks that have dependency arrays, Reason relies on you specifying the arity of those dependency arrays, which basically means like how many variables are we interested in looking at in those dependency arrays. We'll see what that kind of means in this next example. So here's your like classic counter button in React, where you're clicking a button and it's incrementing the count. We see this, we have kind of our use state hook. It's initialized with a function. That's kind of a nuance, but you initialize it with a function that just returns 0. We then have a use callback hook. You'll notice that it's use callback 0. And that's because we basically have no dependency array. The length of the dependency array is 0. And all it does is increment that count by 1, kind of like you'd do in JavaScript. And then we have this use memo1 hook. And it's 1 because we have that count variable in our dependency array. We want to track that in the course of the hook and know when to rememorize this value. So I hope kind of like looking at this, you're like, okay, there's some differences. There might be some things I need to check out, but for the most part, like I can read this as though it was JavaScript. But of course, the benefits are like you get type safety now, and before you either had to write it or you didn't get it at all. So yeah, again, I kind of hope you're looking at this and you're like, this looks like JavaScript. But under the hood, you get a lot more than you do a pure JS. Awesome. So let's wrap it up. I know like we're all kind of short on time here and anxious to get home. I hope this talk has kind of got you excited about trying Reason for yourself and maybe trying to reap some of its benefits. I definitely recommend you give it a try. reasonml.github.io is a great place to start. And they also have a page for Reason React. There's also a Discord, and I would say the Reason community is like the friendliest, warmest community that exists. No egos. The language is so new that people are just excited to bring you in and help you learn. And it's a really, really great community to be a part of. I hope you're leaving here thinking about like, what does it look like to have a truly sound type system? Like TypeScript gives you a lot, but imagine TypeScript without having to write your types. Like that sounds like nirvana to me, and I hope it does to you too. And kind of the last thing, like, if none of this has convinced you, like, it's 2019, so write your React in Reason, you cowards, and get on the hype train, because the train's leaving the station. Awesome. Thank you so much for your time, and don't hesitate to reach out on Twitter, and hopefully I'll see you all contributing on GitHub sometime soon. Thanks so much.